A pristine natural ecosystem holds immense value for the planet, yet left entirely to market forces, it is rapidly logged and cleared. Economists call this failure the absence of environmental markets. Resources vital for human survival often cost nothing, while non-essential commodities, like a plastic bottle, carry clear, calculated market prices. Markets function strictly as information systems, driven almost entirely by price signals. When an asset has a price of 0, the market receives a signal of infinite abundance. Rational actors respond to that signal by overexploiting the resource until it is exhausted. To correct this error, economists use shadow pricing, a methodology for retrofitting a price tag onto unpriced natural capital. Protecting nature within capitalism requires more than moral arguments. It requires hacking the market with mathematically derived prices. The most basic approach to shadow pricing is direct valuation, specifically the contingent valuation method. This method simulates a market by directly surveying populations about their preferences. Economists first measure willingness to pay, the maximum amount an individual would sacrifice to preserve an environmental asset. They contrast this with willingness to accept, the minimum compensation required to tolerate the loss of that same asset. Real-world surveys frequently reveal extreme disparities between what people will pay to keep a resource and what they demand to let it go. These results expose a core failure point. Humans are deeply flawed reporters of their own economic utility. Strategic behavior, or free riding, causes individuals to intentionally underreport their valuation, assuming others will foot the bill. Then there is the embedding effect. Instead of calculating the precise economic value of a local asset, respondents often report high prices to achieve a moral glow from supporting nature generally. Because stated preferences are corrupted by psychological bias, economists must pivot to tracking observable financial behavior. This pivot relies on indirect valuation, also known as revealed preferences. People reveal their true economic priorities not through surveys, but through their actual financial transactions in substitute markets. To value recreational ecosystems, economists deploy the travel cost method. When a park offers free admission, the effective price of entry is the cumulative travel expense required to reach it. A traveler who pays $50 in fuel and 3 hours of time definitively proves they derive at least $50 of economic utility from the site. By aggregating data from thousands of travelers across different distance zones, economists construct a demand curve. This graph maps displacement cost against total visits. The downward slope shows that populations closer to the site visit more frequently. The shaded triangle under the curve is the aggregate consumer surplus, the proven economic value of the unpriced asset. Consider this real-world application at Wrightsville Beach. The calculation extracts an exact aggregate consumer surplus of $666,757 per year for the beach. Tracking geographic movement and travel expenses successfully translates abstract recreation into hard economic utility data. To value basics like clean air and water, economists track aversive behavior, also called defensive expenditures. The economic value of an intact ecosystem is equal to what citizens spend to protect themselves when that ecosystem fails. Regional air purifier sales and healthcare costs related to pollution provide direct proxies for the missing market price of clean air. While effective, this method only calculates baseline health value, ignoring the aesthetic or broader ecological worth of a site. Hedonic pricing captures these broader environmental values. This methodology treats environmental quality as an unpriced public good, secretly bundled into the price of private real estate. Economists evaluate two identical homes in entirely different environments. The market prices of the two homes reveal a significant disparity based on their surroundings. Using regression analysis, economists strip away variables like square footage to isolate that specific price delta. This delta is the environmental premium, the precise dollar value the market places on a view, quiet surroundings, or clean air. Even when society refuses to price a clean environment directly, the real estate market automatically prices it indirectly. These academic tools translate directly into the work of corporate social responsibility professionals. Standard corporate balance sheets often treat environmental damage as a zero-cost externality because standard accounting cannot process unpriced assets. Deploying revealed preference methods injects shadow prices into corporate accounting software. A natural capital line item appears on the balance sheet, populated by data from travel cost and hedonic pricing studies. These shadow prices are fundamental to calculating social return on investment, or SROI. SROI provides the mathematical translation layer required to defend environmental initiatives to boards and shareholders. Environmental valuation tools transform sustainability from a perceived sunk cost into a rigorous, profitable defense of vital natural capital.